Today we're going to go over operations with matrices, basically adding, subtracting, multiplying, dividing kinds of things with matrices. Capital letters are used to name matrices, and subscript notation, those are the numbers that are down below, are used to name the elements of a matrix. Two matrices are equal if they have the same dimension and if all the corresponding elements position by position are equal. To add matrices of the same dimension, adding corresponding elements. Only matrices of the same dimension can be added. So, for example, here we have two 2x2 matrices and we want to add them. Note that the one in the A11 position gets put together, in the A12 position gets put together, the A21 and A22. So it's element by element that gets put together. The additive inverse of matrix A, again using capital letters to denote a matrix, is the values, of course, that would give you the zero matrix when you add the two together, and so of course they would just be opposite sign for each one of those. The multiplication of a matrix by a scalar just means that every element in the matrix gets multiplied by that value. So here 5 out in front of the matrix, all the different elements got multiplied by 5. Now, when actually doing matrix multiplication, in other words, multiplying two matrices, there is a restriction. The number of columns of an m by n matrix A has to have the same number of rows as an n by p matrix B. So note here, this is a 2x2, this is 4x2. The key is there are 2 in a row here and there are 2 in a column there. That is what has to match up. And so the way the multiplication goes is you first take the element here, A11, times the element here, A11, and that's what you see here. And then in the first matrix you move across, so now we're going to take element A12, but that's going to be multiplied by A21. So in other words, this way goes with that way, and all of that ends up being in the first element of the product of multiplying the two together. And then you would take these two and multiply them by those two, and that's what goes into the next one. Then these two by those two, that goes up here, and then these two times those two, and that makes what we have over there. And then for the bottom row, we now take the bottom row here, and so it's these two, 7 and 2 times 1 and 3, 7 times 1 and 2 times 3, and then the 7 and 2 times the 0 and the 1, this is 7 times 0, 2 times 1, and so forth as we move across. Now, we end up with, this is our answer, 1 plus a minus 9 gives us negative 8, 0 and a negative 3, and so forth. Here is our product of multiplying these two. Now, in this particular case, because these are not identical in terms of their dimensions, you could not actually do the reverse multiplication because you would have 4 elements in a row, and there are not 4 elements in a column in this one. So in some cases you cannot do the reverse multiplication. Now if they are the same size, you can swap which one you do. However, you will not get the same answer. So first we have 1, 3, negative 2, 5 times the matrix negative 2, 7, 0, 2. So again, 1, 3 will be times the 2, negative 2, 0. That'll go here. 1, 3 times the 7, 2. That'll go here. And we end up with this product. But if we switch them, and so now we have the second one first and the first one second, so now it's negative 2 times 1 plus 7 times the negative 2, that went there. Note that when we get to the final answer, AB, in other words, multiplying matrix A times the matrix B, did not equal multiplying matrix B times matrix A. So this is not the same as regular multiplication of two numbers. Order matters. All right, some properties of matrix multiplication. As long as the letters remain in the same order, it doesn't matter whether you do AB then times C, or you first do B and C multiplied and then do A times that product. It is distributable, so A times B and A times C, and yeah, that'll be a little typo right there. That should be an A. And of course, here you have B times A and C times A. The key, of course, is we're not actually changing the order of our products. So that's the basics so far of doing add, subtract, and multiply. So let's look at a few examples. So again, add and subtract element by element in the same position in both of them. So here we're going to have the 9 plus the negative 3. And then over here we'll have the 4 plus the 2. Down here, the negative 8 plus the 2. And then over here, oh, excuse me, this is the negative 4. Yep, got to keep it straight. And then over here, 2 plus the 7. So again, here with this one with that one, negative 8, negative 4, 2, and 7. And then our answer, 9 minus the 3, that gives me a 6. 4 and 2, that gives me a 6. Negative 8, negative 4, that's negative 12. 2 and 7, that is 9. And so there's an example of adding two matrices. And as you can see, very easy if you're not paying attention. It's got to be element with element, the same positional element in both of them. All right, let's look at a subtraction. So we're going to have 11 subtract a 0, and a 0 subtract a 12, and a negative 4 subtract 0, and a 0 subtract a 14. Oh, that's a negative 14. You got to watch those signs. And so we end up with 11, negative 12, negative 4, negative, positive 14. And as you can see, the actual operation isn't very hard at all. It's just there's a lot of numbers and you got to keep positional things straight, and so it's very easy to make mistakes if you're not paying attention. Okay, here we have this one added to that one. However, please note there is nothing over here that has these positionals, because this is 1 1 1 2 1 3. This is 1 1 2 1 3 1, so they don't match, so these can't be added. And so some simple adds and subtracts. All right, let's look at some multiplies now. So, again, the way this will work is this row times that column, and then this row times that column. So -1 times the 6 plus the 5 times the 2. And then here we have 7 times the 6 plus 0 times the 2. So again, this one, and then that one, and then this one, and that one. Putting them together, that's going to be -6 plus 10. So that's 4, 42, and 0. So the first thing to note is how we ended up with the same size matrix of the second one that we had in this particular case. But that is how you do multiplication. And it really is a good idea to go ahead and write it out and then go ahead and do the multiplications and additions. That way, for instance, if you're checking your work later on, looking at the answer in the back of the book, kind of thing, and you see one of them's wrong, it's much easier to go back and verify what's going on. Alright, so now this one we can, we could not have added this, but we can multiply because again it's going to be across and then down, so as long as the number of elements in one row matches the number of elements in a column, we can do that multiplication. So in this one we're going to have 0 times -2 plus 3 times the 0 plus -4 times the -1. So note how we have gone across and down in terms of what we're matching up. Okay, so in the next one we'll have 0 and the 6, 3 and the 4, and -4 and the 1. And then I'm going to, let's see, and there's nothing there. This is a separate element in our product. And then our last one, I'll put it down here. We're going to have 0 and 3, let's see, and 3. 3's from over here, plus 3 and 2 and plus -4 and 4. So these times those 3. And put it all together, we have 0 and 0 and 4. And then here 0, 12 minus 4. And then here 0, 6, minus 16. And so there's our answer. So really, you can see that what determines, our answer when they're not the same size has to do with how many elements you went across or how many elements you go down. So 3 and 3, we ended up with 3 this way, but since there was only one row, we ended up with only one row. Here, this one times this one, we ended up with 2 rows, but only one column, because again we had 2 rows there, but only one column here. Alright, so let's look at a slightly bigger case. Now we're going to be doing the multiplication of two 3 by 3s. So, again, it's a really good idea to give yourself some room when you are doing this. So, first off, -1 times 2 plus 2 times 0 plus 0 times 3. So those 3 times those 3. Okay, moving across, I have -1 times -1 plus 2 times 2 plus 0 times 0. And so now it's that top row against the middle column. And then finally, we're going to have -1 times 2 plus 2 times 1 plus 0 times the -1. And so here for that one, here for that one, and then here for that one. And then notice the similarity. The first part of each one is the same as we go across this way. Alright, now we do our second row. So we're going to have 0 times the 2 plus 3 times the 0 plus 2 times the 3. And then here, 0 times the -1 plus 3 times the 2 plus 2 times the 0. And then here, 0 times the 2 plus 3 times the 1 plus 2 times the -1. And our last group, so this last row, 0 times the 2 plus 1 times the 0 plus 4 times the 3. And you can see that as you go down, it's the second numbers that have to be the same each time. And then here we have 0 times -1 plus 1 times 2 plus 4 times 0. And then finally 0 times 2 plus 1 times 1, and finally 4 times -1. And so there are all of our individual steps. Now let's go ahead and simplify. So -2 plus 0 plus 0, -2. 1 plus 4 plus 0, 5. -2 plus 2 plus 0, 0. 0, 0, 6. 0, 6, 0. 0, 3, subtract 2. 0, 0, 12. 0, 2, 0. 0, 1, and -4. And so, when we multiply a 3 by 3 times a 3 by 3, we end up with a 3 by 3. A 2 by 2 times a 2 by 2 would end up as a 2 by 2. Alright, finally, given that a is 4, 3, negative 2, 1, find a squared and a cubed. So, first off, a squared is going to be a times a. So, that's going to equal 4, 3, negative 2, 1. 4, 3, negative 2, 1. And that will be 4 times 4 plus negative 2 times 3 for that element. 4 times negative 2 plus the negative 2 times 1 for that element. And then 3 times 4 plus 1 times 3. And here 3 times negative 2 plus 1 times 1. So a squared is 12 minus 6, let's see, no, 16, sorry, 16 minus 6, so that's 10. Negative 8, subtract 2 more, negative 10. 12 and 3, 15. And negative 6 and 1, negative 5. And so there is a squared. Okay, so a cubed would equal a squared times a, so that will be 10, 15, negative 10, negative 5, and then 4, 3, negative 2, 1. This will equal 10 times 4 plus negative 10 times 3. Over here we'll have 10 times negative 2 plus negative 10 times 1. 15 times 4 plus negative 5 times 3, and then here 15 times negative 2 plus negative 5 times 1. So a cubed will equal 40 minus 30 is 10, negative 20, negative 10, negative 30. Here is 60 minus 15, so 45. And here is negative 30 minus 5 more, negative 35. So there is a cubed. So, adding, subtracting, and multiplying.